I don't remember
the question that motivates our discussion today is how do we work with class data? That is the kind of things you set up in these classes, frequency tables with like ranges, bins of data. How do we work with bins of data and calculate statistics using that kind of input? That is, how do we calculate in particular the mode, or the mean, or maybe the median and the quartile. That's what the motivating thought is today. Cassie, this is not on the quiz. Even though it's not. All right, I think everyone has the resource that I've just passed out. And now is the time, I think, too. It does say, actually, I think maybe Franklin, you did it wrong. 889.48. It's in the second paragraph under number 2 at the very end as a parenthetical comment. 889.48. That was close to what you said, I feel like, but not quite. So the person who got it right was the 890, and that person was that Annabelle?
Yes.
Okay. So you get a prize from the prize bin. There you go.
I've never done something.
What's wrong?
They're
there now.
They are?
The homework 1 solutions, it was just asked. The homework 1 solutions, yes, are posted right now. Right now. You can go there. I posted them this morning. Why is that here? You'll catch up. She'll take the quiz tomorrow. She'll do a great job. Okay. So good job, Annabelle, and good job, everybody. Everybody's aware, okay? Especially Annabelle. Okay. So let's turn our attention to the question at hand, and that's how do we from class data or binned data, grouped data, there are a couple ways to say it, calculate various statistics.
the people we threw in a bag.
Listen, and hear why we've already done some of this, okay? First of all, we've already answered the question in some sense what we mean by the mode. What do we mean by the mode for class data? We don't really mean much. The only thing we can talk about is maybe a modal class. So mode, let's just check that off the list. We kind of talked about what we mean by the mode when it comes to class data. What about the mean? Well, we should say more about that, and we will in a second, using a method we'll talk about. If we don't have access to the actual data, are we just left to guessing? That's kind of maybe that's your inclination. But what can we do that's more systematic? That's going to be the first question in a minute. But I guess before we even do that, before we even actually go to calculate the mean, we should maybe motivate this a little bit, this topic. Because you're thinking, wait, hold on. I could be like a Franklin. I could just like calculate the mean or have a machine do it with all the data. Even if it was a lot of data, I could probably do that. So maybe if you had a ton of data, you'd be like, well, I don't really want to do that. So that might be one reason to do what we're going to do today. But the other reason is, yeah, Ian, you're right. What if we don't actually have the data? If we don't have access to the data, or if we never had it in the first place? Can you imagine having binned data that came to you, and on the moment of recording the data, all you had was binned data? You've never actually had the actual data points yourself. How could that have happened? Explain a situation where you've taken a survey like that, where on the point of data entry, the very moment of the asking of the survey, all that the survey giver is getting from you is binned data. I'm intentionally being vague. Give me a concrete example of when that happens, when someone asks you a survey question. And you're not actually giving a value, you're giving a binned value. Yeah, I mean that's kind of the classic example. On a survey like that, they don't. The experimenter walks away with data that isn't actually the data, right? Like so afterward, if you check the box, yes, I'm in between 7 and 12, and then someone else checks I'm in between 13 and 18 or something like that, and you're checking these boxes, right?
You just check all of them and ruin the data set.
It's a radio box, you can only check one. So that's how the form is
And
validated.
just
Sorry.
lie.
The person who
Everybody
has,
lies.
the person who receives that data doesn't actually have access to the ages, and so if they ask what was the average age of respondents, they wouldn't know. Even though they got the data, they have the data, and yet they wouldn't know the average age. They wouldn't, because everyone just checked an age range.
Like the average is 7 to 12. No, never mind.
I'm just saying, like, if you took two people who took the survey, and one of them said, I'm between 7 and 12, and the other said, I'm between, like, 13 and 18. What's the average age of the survey response? I mean, with 2 people, we're not sure.
Between those two.
Somewhere, yeah, somewhere in there, maybe. Could be anything, though, right? So give me a method. How would you do that? For the mean. For example, focus in on the histogram, which is number 14 from last night. It's not reproduced on the top of this page. Let's focus on the 5th class that had families that had this usage for their energy between 770.5 kilowatt hours and 810.5 kilowatt hours. What representative, if you don't know what data is in there, then what would you like to pretend they all are? Yeah, maybe the middle number, for lack of a better number. And so, I don't know, I think you would have done this even without my help, right? So that's what we'll do. We'll use as a representative for each class the mid-interval value, or the class mark. 2 names for the same thing. So for that particular class, that 5th class, that bar, let's pretend all 5 families had this as their energy use for that month, or whatever it is. Does that make sense? And now let's do that for all the classes. And then use those and pretend those are the values and find the mean of those. This is how you might do it, right? Good. Visually, I am wondering though, how did you guess? Did anyone have a non-random guessing method that actually produced what was your intuition as you did it? Were you just kind of like randomly guessing, or did you have a strategy at all? What makes one of the guesses written on that warm up better than another in your mind? Annabelle, she's the winner, so ask away.
Okay. Well, the data is mostly like symmetrical in the middle, and so if you have if there was one that was higher than all the others, and that one was in the middle, that would be traditionally what it was like. If they were all the stereotypical graph, but it's not. So you have to account for the fact that a little bit more of the data is on the right side because that's where the modal class is, and so it would be more towards the end of the middle graph.
Yeah, I think I hear what you're saying. You're aren't you dying to know what that is? Yeah, I mean, we talked about this a little bit yesterday. We said the mean is here for a symmetric distribution, but then if we skew it to the right a little bit, then the mean is there a little bit, right? She's saying it draws away from the center. Is there a way? Have you thought about this before in physical terms? Is there a way to visualize where the mean's going to be if I just draw a blob up here? Say there's my distribution. How would you make a intuitive? If there are no numbers here.
I think you should balance it.
Balance. Do you think that the balance point has something to do with it?
Yes.
Right. You can imagine this being like a teeter-totter. It's so exciting, right? And it's balancing on the mean. Yeah. So, and you can see why now too that the mean gets drawn away from the center. If we draw this lump down here out further, then in order to balance using kind of physical principles, we'd have to have that happen. Yeah, so I did cut out a picture of the number 14 histogram. There it is. Do you like it? In all of its accuracy and glory. You don't have to class my cutting skills, but I thought I drew the mean on here too. Would it be nice if it just balanced there or something? It doesn't, but I'll pretend, and this will be a visual that will help you remember this principle. Here we go. Because Mr. Chase likes to be do goofy. In truth, though, thank you. Here all week. Okay. In truth, it actually balances anywhere, though, if you really make it happen. Oh my God. We're going to break it.
Can you do that while juggling down a unicycle?
You're asking a lot. I can do it while teaching math.
Can you do it while juggling on a unicycle and teaching math?
Let's proceed now to actually calculate the mean using this method and see how close it gets to whatever it was, 889.48. Let's see how close the estimate is. So go ahead and do this on the next page. Do you see on the next page? There's a table ready for you, and it already has all the class marks written down for you, including the 5th class, which we just talked about, 790.5. But now copy all the frequencies over. What? It's not the 5th class. It's 3rd class. That's what I meant. So go ahead and copy the frequencies over. Multiply them. Find the mean the same way you've always found the mean. And then when you're done, like it says, check with your neighbor and see that they got the same. I'll give you a minute to do that.
They're wrong. They are wrong.
It's circular, it's very rapid. Why? I didn't think so.
What's the total frequency?
Carry that one.
What do you mean star?
I need to know by Friday.
What you got? 89.3.
Look. I encourage you to read it. What did you get? Did you get an answer yet? I'm just anxious to know how close this comes to the. There is a shortcut here, isn't there?
Where?
Can you still use one bar stats for this? I mean, you could, right? And just load the data in as the class marks if you wanted to. I mean, that'll. I'm just suggesting that you guys like shortcuts and being lazy. Maybe you would think about it. Now that you've already done it, though. 891.3 is what Ivy's getting. So what you got? No, it isn't, Leo.
I think got it. I think I did it right.
Well, I don't know. She could have missed. It's very easy for someone to miskey something, so you don't know. What'd you get? We're not going to be done until someone else can confirm that.
I got it.
Oh, really? Yeah, okay. 891.3. And is that, or is that not close to the actual mean we suggested, which was 889.48? It's not bad, right? So I hope you see that even though this seems like a last-ditch effort to just like pretend the data is all in the middle, it's actually, especially with large sets of data, it's actually not that bad. If we have decent classes and decent data, and it works out. I have nothing more to say. Well, actually, no, I forgot. There's always something more to say. What did you notice is the distance between? We're supposed to ask this question on there too. What's the distance between the class marks? And what is that also? Is that a coincidence? That's also the class width? No, maybe you can see why that will always be the case. That does provide a shortcut. Do you see why? If you're looking for class marks, if you find the first class mark and you want to find the others, you don't have to keep averaging them. You can just add 40 to one class mark to get the next class mark, right? Does that make sense? So that provides a very quick shortcut for you if you notice that that's true, okay? What else do we want to say about that? The other thing that's on there is it asks too at the bottom, what about the standard deviation? So one way to do that would be to take each class mark, subtract the mean, square it, multiply by the frequency.
Wait, go slower.
Who said this before? But I'll say. Take the class mark and subtract the mean, then square it. This is just the standard deviation formula, right? Times the frequency. Add them all up. In this case, divide by 50. And then, if you want the standard deviation instead of variance, take the square root. Isn't that the formula for standard deviation? Okay. All right. You can just use one bar stats too. With the class marks in L1 and in the frequencies in L2, right? And then that'll give you the standard deviation too. So whatever. The O thing? You mean the sigma? The O with the hat. The beret wearing a O. Yeah. The O with the slicked haircut. Whatever. Yeah, exactly. All right. It's important that we spend the last part of our class. Thank you for your attention, people and friends. Let's listen here as we think about the median and how to calculate that. So this is actually a little bit of a chore to do the median and the quartiles and the deciles and all that kind of stuff. So let's carefully do this. We're gonna be drawing something called a cumulative frequency diagram. It should actually not be surprising that we need right now the cumulative frequencies because we've done this before. When we're doing like the television 600 pieces of data survey thing, we underneath that table we generated the cumulative frequencies, and at that time I think we all saw how useful it was to have cumulative frequencies then in finding the median or the quartiles or whatever. So we're going to do the same thing. This is class data, but you can still already maybe see why this is going to be useful. So go ahead if you haven't already done so and start filling out this table. I'll do the first one for you there, 9. That one's 50. There you go. You're welcome. Remember, each one is the number of items in that category and below. All right, how'd you do here? 19. Did it add up to 50 in the end? Did it work? Did it work? It's working. Yay. Okay, good. So those are the cumulative frequencies. And now, are you ready? We're going to plot. Please pay attention carefully because this is important. Are you ready? We're going to plot the upper class boundaries against the frequency. So x, comma y, x, comma y, x, comma y. So plot these points as points over here. I've set up a scale that's like decent. It's actually not the world's best scale, but whatever, we'll go with it. The point is, as accurately as possible, plot these points, okay? Including one more point which is not on our list, and that's 690.5, comma, something, 0, right? Because by the time we've gotten up to 690.5, we've gathered no data, right? So that's an important thing to say. And then as we move from the piece from 690.5 to 790 to 730.5, we've collected one piece. You see what this is doing. So go ahead and carefully plot these, as best you can. You can eyeball it a little bit. That's like around 690. That's fine. Whatever. 730. Just make careful note of the scale you're using, whatever scale you're using. 810. Oops. Okay.
Don't feel bad. I screwed mine up in 10.
7. Oh, that's supposed to be 1. Oops. I have 1 to erase there. Be more careful than I am. 810. What? What's wrong? 850. 19. It's really hard to see, huh? 890, 22. 890.
It's okay. I draw all of my pictures of ninjas in my crayon.
930, 33. 930.
I drew like a couple hundred ninjas.
970.
Very well. You never see.
What kind of progress are you making out there, people? 970, 41. 1010. 46. 2. What's wrong? Upper class limits, yeah. 1050, 49. 1050. I know, this is 2, 4. Oh, oops. And then 10, that's not there. And then 1090. All right, I think I did it. How'd you do it? Did you beat me to it? It's hard up here. Does yours look something like mine? Yeah? All right.
I have 2 points.
Yeah, the scale is crazy, right? And then when you're ready, connect it as best you can with a smooth curve. That is, don't connect it with a line. Do your best to do non-linear interpolation, right? That is, just connect it as smoothly as possible, okay? And now, break out your straight edge. I have rulers over there, but just use something straight in your life, okay? your warm-up notebook or something. You're already using the pencil. I like that. That's good. You put it to work right away. I like that. All right. Now, where are we going to find the median? Let's actually now talk about why this is useful. Where's the median going to occur? If we have 50 pieces of data, by the way, it's really convenient that we have 50 pieces of data. That's nice. It'll happen exactly, yeah, like half the way through. For us, that would be 25. So that's here. How about? So we're going to all disagree just a little, but we shouldn't disagree a lot. I don't know. You'll catch up this one. Okay. So come across then of the 50% point, and then drop down. It looks like I'm like just a hair before 912. I might say 910, something like that, for the median. What are you guys getting for the median on yours?
I'm not, but I screwed up my own guy.
I'm getting about 910. If you got something in that neighborhood, if you got like 700, you're wrong. But if you got like 905, you're probably forgiven, right? Like mine is probably certainly a little off just because of the way I drew it up here, and I'm making some small errors, I'm sure. So probably anything between 900 and 920 is probably like fair game for the median. So hopefully you got an estimate similar to that. And now let's do one other one too. What about like?
Mr. Chase,
what else would you like to do? Q3 something? I don't know. Q1?
Q1 and Q3.
Yeah, we can grab Q3 here. So that's 75% of the way through the data, right?
We're at 37.5.
We can go find 37.5 right there. Come across again and down. This is Q3. It looks like it's around, I don't know, 940 something. Let's say 946. Something like that. Yeah? Again, you do it too and just tell me whether I'm crazy, okay? Is that right? 946? Did you do something in that neighborhood? No one's there yet. Annabelle's still trying to catch up. Alright, it's okay. You guys can do it, I believe in you. The only other question I might ask is, what if I wanted to know the reverse question too? What if I'm a household that does like 1050 kilowatt hours? Could I figure out what percentile I'm in? I think you could do the reverse question too, couldn't you? Yeah, we will check this homework until Thursday, right?